Welcome back to the deep dive. Look, if you spent any real time with a large language model, maybe trying to get it to structure a complex report or, write code that follows really strict rules, or
That's exactly the angle because, the sources we're looking at today, folks like Iovane and Iovane, and some really key empirical stuff from Sheff and his colleagues from 2024, they make it crystal clear that just like rewording your question isn't going to cut it, not for complex stuff. If we want these layered, multi-constraint outputs, we have to go deeper than just surface tinkering. We need to explore the structural, the conceptual elements of crafting these instructions.
Okay, so our mission today, unpack the hard evidence on why prompts fail, and then explore how these more sophisticated design techniques, drawing on history and philosophy even, are used to shape demand so the AI can actually deliver. Let's start with the tough numbers. Why do those simple, intuitive prompts fail so often? What's really going on?
Well, the problem is pretty much routine, and the data is, well, it's jarring. Sheff and colleagues in their 2024 work tested GPT-4 really thoroughly. They gave it tasks needing multiple specific instruction constraints, and they found the model failed to hit all the constraints in, get this, a staggering 99.4% of cases.
Whoa, hang on. 99.4% failure for complex instructions.
Yeah.
That's not just a glitch. That's basically the system default, isn't it? It suggests if you're asking for anything more than a basic summary, you're almost guaranteed to be let down initially.
Exactly. That number just slams home the point. Naive prompts predictably fail. It tells you the model gets fundamentally confused by complexity unless you really, really hold its hand. So sophisticated prompt engineering, it has to do all that heavy lifting. It needs to encode the context, the tiny details of constraints, the overall goals, and, crucially, how they all link together right there in the instructions.
Okay, so if I just type, write me a report on solar energy, that's naive. The LLM gives me back generic text. But using sophisticated PE, what am I actually adding? What does that look like?
You're adding structure explicitly. So instead of just the topic, you might say, write a report that's the goal aimed at executives, that's the context focused on the economic viability of solar energy constraint 1. Make sure the tone is optimistic but financially cautious constraint 2, and format the main conclusions as exactly 3 bullet points constraint 3. PE becomes this vital bridge, as Largy and Dattery point out. It connects your big picture goal with the super detailed instructions the model needs to actually fulfill it.
And this bridge, it has to connect two pretty different levels, right?
Yeah.
The level of language, what we type, and the level of, action.
Precisely. Prompt engineering has this job of bridging the high level of our linguistic instructions, the words we use, and what the sources call the lower level of action affordances.
Okay, hold on. Action affordances, let's unpack that a bit. For a machine that just processes text, what does action affordance actually mean?
Think of it like this. The LLM crunches text. Yeah, but it's trained on massive amounts of data describing real-world stuff, concepts, actions. And action affordance is basically what the model can realistically do based on its understanding of language. So when you ask it to summarize, it understands the action of summarization. The problem comes when constraints get tricky, like summarize this, but keep the exact chronological order. The model struggles to map that complex language onto the practical steps it needs to take. Good PE fixes this by embedding cues about the context right into the language of the prompt, guiding the model toward the right set of, internal actions.
Right, and this is where it starts feeling less like coding and more philosophical, because we're asking the system to align its digital actions with our human intentions. How does this whole effort become, as you said, a kind of historical, philosophical approach?
Well, the process itself, it's inherently iterative. It's conceptual work. Think about the back and forth you need to get a complex prompt right. You try something, it fails, you clarify your intent, you try again. It really mirrors a kind of Socratic method, doesn't it?
Yeah.
Vinsky talked about this focus on clarifying intent. You're not just barking an order, you're in this cycle of exposing the intent, as he put it, over and over. You're kind of forcing the AI to help define the problem space with you.
That makes a lot of sense. We're basically using the prompt to translate our own often messy goals into clear step-by-step instructions for the machine. But if we're taking this Socratic path, what non-technical things do we have to build into the prompt's architecture? What grounding elements?
We absolutely have to integrate what Largy and Dattery term philosophical principles and ethical frameworks. These aren't just nice to haves, they're essential, because the LLM, left alone, just defaults to statistically likely output. That output might not be practical or safe or ethical, so we need these frameworks to mediate between our abstract human goals and the concrete actions the machine takes, to keep it aligned with our values.
That's really fascinating. But how does something seemingly academic like, say, phenomenology or hermeneutics actually end up in a functional prompt? A string of text. Can you give an example?
Sure. The sources point to using these ideas to explicitly encode concepts like intentionality, temporality, and effect. Intentionality is about defining the why behind the task, the specific purpose driving the model's choices, not just the what. Temporality is maybe even clearer. If your prompt needs the AI to understand a sequence of events, what happened before, what's happening now, what needs to happen next, a simple prompt just falls flat. But a prompt informed by, say, phenomenology might structure the information explicitly. It might label the starting context as past situation, the current state as present context, and the desired outcome as anticipated future state.
Wow. Okay, so you're literally structuring time within the command itself. That feels like a huge leap from just asking for information.
It is. Because you're supplying a conceptual map, a structure the AI likely won't generate correctly on its own. You're guiding its journey through time, essentially.
Okay, so let's say we've done all this. We've poured Socratic effort in, we've wrestled with intentionality, structure, time, built-in constraints, we've engineered the heck out of this prompt, but we still hit a wall, right? The technological one. What are those persistent structural limits that even the best prompt engineering seems unable to fully overcome?
Yeah, even with all that effort, the sources flag two core, really stubborn limitations. The first one, the most obvious one, is hallucination. This just seems to be a fundamental problem, technically and maybe even philosophically. Salas-Guerra points out that even when you explicitly feed it facts or constraints, the AI's output often isn't faithful to the source material. It's not factually accurate, or it's not genuinely actionable in the real world. The model seems to prioritize making sentences that sound plausible based on its statistics, rather than sticking strictly to external truth.
Right. That's the classic failure mode. We all see the AI confidently making up names, dates, sources that just don't exist. Okay, so what's the second big persistent issue, especially for those complex multi-step tasks?
The second one is the persistent lack of memory. This gets really frustrating when people use more advanced techniques like instruction chaining. That's where the output of one step automatically feeds into the next.
Can you explain instruction chaining a bit more? How does that work?
Sure. It's how you try to get the model to do a complex sequence. Like, step 1, analyze this data. Step 2, based on the analysis from step 1, generate a summary. Step 3, now edit that summary based on these new guidelines. But both Buckner and Sheath et al. Point out this problem. Even with bigger context windows, the model often struggles. It kind of forgets the overarching goal or the detailed constraints you set way back at the beginning of the chain. It's almost like talking to someone who's incredibly smart but has severe short-term memory loss. They can execute the current instruction perfectly, but they lose the thread of the overall conversation from 5 minutes ago. And that seriously limits how well you can automate complex, multi-stage processes.
So the bottom line from the sources seems to be that even after throwing the entire prompt engineering playbook at it, these generative models still struggle to consistently produce outputs that are, quote, practically feasible, ethical, or situationally appropriate.
Exactly. And this consistent failure, it points towards something deeper than just bad data or insufficient training. It hints at a fundamental limitation in the whole underlying approach, what Daskal, way back in 1989, called the symbolic empiricist epistemological paradigm. Basically, LLMs are amazing at finding statistical patterns within language itself, words predicting other words. But they struggle to connect those patterns reliably to an extra-linguistic referent.
Okay, extra-linguistic referent, that sounds like some heavy philosophical jargon.
Yeah.
What does that actually mean for the AI in simple terms?
It means they lack real grounding in the world the language is about. The model knows statistically that the word apple often appears near the word gravity. It knows how those words pattern together in text. But it doesn't truly grasp the concept of an apple falling, the physics, the consequences, because it has no connection to that physical reality. It's all just word association deep down. So unless the prompt is incredibly explicit and basically does all the conceptual work for the model, it just keeps aligning its internal word statistics rather than connecting back to actual meaning or real-world application.
Which brings us, I think, to the highest ambition of prompt engineering. If the technical fixes aren't quite enough because the problem is this deep, this epistemological, then how should we think about the prompt itself? Is it just code or something more?
It really has to be seen as both. Prompts are, at the same time, technical instruments and conceptual structures. They're our main interface, maybe our only interface right now, for injecting those deeper philosophical considerations, ethical rules, temporal understanding, structural constraints into the purely statistical engine of the AI. The prompt designer becomes a sort of applied philosopher almost. They're taking abstract ideas like different ways time can be understood, maybe drawing on phenomenology, or even older historical accounts of time, as Atherton suggests, and embedding those complex models into a simple string of text to guide the neural net.
So by forcing this blend, history, philosophy, technical design, all aimed at tackling these deep knowledge limitations, this whole advanced prompt design effort starts to look like something else, something our sources call Sophimatics.
That term really captures the ambition, doesn't it? Sophimatics, as Daskal framed it, is about trying to bridge the gap between mere statistical association and actual conceptual understanding. In a way, the sophisticated prompt is our current best human attempt at achieving Sophimatics with these tools. We're trying to push the AI beyond just playing word probability games and force it towards behavior that's genuinely meaning-aware and intentional. The prompt, this blend of concept and technique, is our tool for encoding that necessary structure to maybe, just maybe, make that philosophical leap happen within the machine.
This has been absolutely fascinating, a real deep dive. I think the big takeaway for me and for you listening is that prompt engineering isn't just about clever keywords. It's this complex attempt to make a statistical machine act conceptually, act ethically. The real skill seems to be in encoding the circumstances of operation, the whole context, the why, the how, not just the task itself, and understanding why the model fails at that fundamental level.
Absolutely. We've seen it demands this truly multidisciplinary view. You have to go beyond the technical tips and tricks. You need a deeper grasp of how AI fails, philosophically speaking.
Yeah.
When you're crafting a really sophisticated prompt, you're essentially wrestling with the cognitive architecture, or lack thereof, of these powerful but limited AI systems.
Right. And maybe the final thought, the provocative one, based on these limitations, if even our best prompting efforts hit these walls, hallucination, memory loss, does that mean we're just patching a fundamentally flawed system? The sources hint that the real breakthrough might require tackling the problem deeper down, at the level of cognitive AI itself. Moving beyond current neural nets to design systems at the symbolic level, systems capable of genuine understanding. So the question we leave you with is this: is the prompt just a clever band-aid, or is it actually showing us the blueprint for how to build truly intelligent systems in the future?